information you have is here, is along this axis, is along the length of these two control points. So because you have these two, so you know the scale of this direction, and you know the rotation of this direction. Okay? So what we don't have is, like I think Zhenyong is trying to say, so a fine transformation is not, it separates the axis, the two x and y axis, and determine their rotation angle and scale independently. So, which means that we need more information to define the other direction and the perpendicular axis of the perpendicular axis. Which means that we need, so right now the rotation and also the scale, different scale information is obtained along this line, along this axis. However, whatever rotation angle changes and whatever scale changes for this direction is unknown. For this perpendicular axis is unknown. So in this case, we need more information. And that more information can be found by having, for example, another control point. Another control point. And these additional control points gives you two more equations. But right now it's a fine, actually. Right now it's a fine. So I will just draw it like that. Right? So in this case, you can have the rotation angle and also you can have the rotation angle information for any two axes. Doesn't matter if it fits with the new axis, x and y axis, or any other axis that you have. And also the scale differences for any axis can be defined by using these three. So there's actually an additional question. So if right now the control points, that the third control points that we have is not over here, instead it's over here, and they are collinear. If the third one is over there, what's the problem? From the mathematical point of view, it seems like, yeah, you have six equations to solve 6 unknowns. So supposedly you can solve it, right? But however, from the geometric point of view, because they are collinear, so the information it provides is the rotation and also the scale changes along this axis. So for the perpendicular axis, you don't have any information, you don't have any clue about the rotation and also the scale. Okay, so that indicates, say, if you are solving the affine transformation parameters, of course you need at least three control points. But those three control points, they cannot be collinear. They cannot be collinear. Right? So the third control points cannot be here. Okay. That's actually pretty important. You can try, of course. Actually, for our homework, which we haven't touched. Actually, what I'm trying to teach you guys is about some background information for your homework. So to understand what's the requirement for the homework. So for the homework, actually, you are going to write the affine transformation. And in this case, and to understand the the behavior of the arrow behaviors of using the affine transformation function. And in this case, you can simulate control points to solve the affine transformation parameters by having them as the collinear control points. Then try to observe what's the arrow behavior. And if you add just one control point which is not collinear with others, then in this case, observe that arrow behavior. And you will see, supposedly, you should see a significant improvement in terms of the coordinate transformation. Okay, supposedly, that's the hint for your for what you can do for your homework, actually. Okay, so okay, is it any questions? Any question? All right. So from the mathematical point of view, of course, you need 3 control points to solve 6 unknowns. And then from the geometric point of view, yes, you need 3, but also these 3 cannot be collinear. Okay, so that's the case. And in terms of the 2D projective transformation, it's actually the same idea. So you need, if you want to solve the 2D projective transformation parameters, then you need 4 control points, because 4 control points gives you 8 equations, and 8 equations can solve 8 parameters. So at least 4 control points. But still, the idea is still the same. The 4 parameters, they cannot be collinear. They should not be collinear, because if they are collinear, they only define the information for that collinear axis, for that collinear line, actually. And whatever perpendicular to that line is not, you don't have any information, you don't have any clue. So then in this case, you don't have the, in this case, the arrow that's perpendicular to the collinear line will have large arrow. Okay? So to summarize, right now, okay, so 4 parameters, which means that 2 GCPs, 2 control points. Let's just say control point then. 2 control points, 3 control points, 4 control points. And in terms of the 3 and 4, non-collinear. The 3 control points and 4 control points, they should not be collinear. Any question? No. If no question, then let me ask the next question, which is, right, so right now, in terms of the control points, the distribution of the control points. Okay, so imagine right now, this is your area of interest. This is, the whole thing over here is the area of interest, and also the same thing over here. So these are the same area, but just with different control point distribution, right? With different control point distributions. So in this case, one is more concentrated over here. So 4 control points concentrated on this at this corner, and then the 4 control points scattered, like pretty scattered around this area of interest. So in this case, what's the difference between them? What's the difference between them?
I think in the right one is better.
Why?
Because you can control the big area.
We can draw a big area?
Yes.
What do you mean by draw a big area?
I mean, if you control all in certain part of area,
Yeah.
it's maybe some incorrect in another don't have control.
Why?
I think it's depends on the scale.
Depend on what?
The scale.
The
of
scale?
Yes.
Depends on the scale. Scale may not be the scale though. May not be the scale. So what's the good thing about this distribution? Any good thing about that distribution? Oh no.
Maybe it's more like better accuracy. Maybe.
Better what?
But just better accuracy.
But-
Yeah, but only this small area.
Okay, so you have the better collinear transformation
Yeah.
for this area, right?
Yeah.
So yes, right. The good thing about this type of transformation is it has pretty good accuracy over here, right? In terms of the collinear transformation, of course. But however, outside this area, it's like collinear transformation function. The control points is to give you the information to describe the relationship between two coordinate systems. And if you are concentrated at a specific region, then of course, if they have the same amount of control points, then you can describe the relationship between these two these coordinate systems pretty well out here in this region. But however, for whatever outside that concentrated region, you are kind of like guessing or trying to extrapolation, right? You are trying to use extrapolation to understand the behavior between these two, the relationship between these two coordinate systems. So whatever information that is derived from the extrapolation is like kind of like guessing. It's kind of like guessing. So the arrow behavior, the arrow will increase, usually will increase. Okay. So in this case, if the whole region is your area of interest, if the whole region, so pay attention to the assumption, if the whole region is your area of interest, then in this case, the more evenly distributed and also that covers the whole area of interest, this is a better choice. But however, if right now your area of interest is here, is focusing on just over here, then more control point focusing on this region, then actually that's a better solution or better choice. Okay, so it really depends on where your area of interest locates. Okay, then the next thing is I believe we haven't defined a term, which is the there's a term that we haven't defined, which is the degree of freedom. I guess, I think we haven't defined it. So degree of freedom, DOF, or in Chinese, the Chinese class again, so it's called 自由度. Freedom is 自由, like freedom, and 度 means degree, right? So it's like next one, 自由度, okay? So, what is degree of freedom? Let me ask, what's your degree of freedom? We talked about that in the surveying practice course. So, you should know it. 自由度, what is that?
In photogrammetry.
What? It's the same thing, actually. In photogrammetry and also in the surveying and also surveying practice, we are talking about the same degree of freedom. Actually, this is from the mathematics. Well, it's from math, actually. So the definition is the same. So, what's the definition of degree of freedom? Yes?
I would think like the amount of error you can have.
No, it's not about that. It has a very strict definition, or well, very simple and clear definition. You forgot?
Yeah.
Okay. I'll find another TA. 第三 degree of freedom. You forgot as well? Okay, I will find 玉婷. Come on, I spent some time to explain degree of freedom to you guys.
The area of
Someone.
The relationship between the observator and the object distribution.
No. 朋友.
Number of observation minus unknown.
Number of observation and
Minus unknown.
unknown. What unknown? Unknown. Number of unknowns. Right? Okay, so the definition is actually very clear, and supposedly TAs should know it. Actually, TAs should know it. I already teach the undergrad students these today, so they may ask you what is degree of freedom in your surveying course, surveying practice course. Number of observations minus number of unknowns, right? So the degree of freedom is the number of observations minus the degree minus the number of unknowns. So in this case, as you can see right now, if we have 2, 3, and 4 control points, and we have 4, 6, and 8 observations, which are the equations, right? So we have 4, 6, and 8 equations, and also means the number of observations. And in this case, how many unknowns do we have? 4, 6, and 8. So in this case, for these control points, the number of control points, that's the minimum number. That's the minimum number that we need to solve the unknowns. But usually, we in surveying or in any by any surveying, like the photogrammetry also include in the surveying. If you talk about that, talk about it like that, then what we usually are trying to get is the more degree of freedom. Then more degree of freedom means more redundancy. Redundancy. The spelling is right or wrong? Right? Okay. Redundancy. Okay. Redundancy means in Chinese it means 多余关字, right? The extra information like that. Okay. Redundancy. So usually in surveying, or in photogrammetry, we want more redundancy.